The topic for this screencast is air pollution, and the following objectives will be met by students. Students will be able to define air pollution, identify the major air pollutants and their sources, identify ways to reduce air pollution, discuss the impact of pollutants on human health and the environment, and understand the processes of smog creation, acid deposition, and ozone depletion. We will begin with a case study of Chattanooga, Tennessee. Chattanooga, Tennessee is surrounded by mountains that make up the Appalachian mountain chain. The one that you see in this picture is called Lookout Mountain, and as the name implies, people could climb up and look out for great distances. However, that's how it looks today, but that wasn't how it always looked. Chattanooga is a city where industrialization began in the 1850s. As it did in many places in the United States. They made textiles and did metalworks, and this produced a great deal of air pollution. The air pollution made the area so polluted that you couldn't even see Lookout Mountain from a quarter of a mile away. So cities like Chattanooga had a problem. They had lots of pollution from lots of industry, and they were surrounded by mountains. So when the wind would normally in other places perhaps disperse the pollutants downwind, they weren't doing that in Chattanooga. So it became very, very polluted. And this was before the Clean Air Act of 1970. There were a group of citizens and government leaders that believed that the city's air needed to be cleaned up, and they took action to do so. The price tag was around $40 million, which is pretty high, and many people were concerned that it would cost too much to actually clean up the pollution, and it would put businesses out of business because it would be too costly for them. But in fact, what actually happened was that the city just reinvented itself and the type of industries that it had. And so it produced things like smoke scrubbers, some technologies that were used to clean up the air. They were invented here and produced here and fed the city's economy in new ways. So it turned out to be a win-win. And let's see. So as with all of our case studies, there are a few take-home points that I would like you to think about and remember those as we go through the chapter. So let's take a look. You can put the video on pause if you'd like to think of some on your own. One of the main points is that air is a global system. The air that's in China will eventually be the air that's in the United States, which will eventually be the air that's in Europe, and vice versa. Air moves all around the globe, and there aren't even any barriers other than a few mountains to the flow of the air. So that's an important point to keep in mind. A second point to keep in mind is the tragedy of the commons. So air is a resource which is held in common. It's not owned by any one person or industry or country. And as such, being a commons, the air may get overpolluted. That's the tragedy of the commons. When a resource is open and available to anyone without restriction, then often that resource becomes depleted or damaged. The third takeaway point here is that the public, the local government, and businesses can work together to clean up. Chattanooga here is definitely a success story, and other places can be as well. But air pollution is a complex series of events and processes, and so it would be best to prevent rather than have to just clean it up. And we'll look at some of the ways that that can happen. So we'll begin this topic by looking at a definition for air pollution and then looking at the common sources of air pollution. So first we have a very important vocabulary term. What is the definition for air pollution? You can put the screencast on hold and take these down or read through them on your own, and then click back on and I will go through them. So air pollution is made up of chemicals, particulate matter, or microorganisms that are found in the atmosphere at concentrations that are high enough to cause harm to plants, animals, and materials such as buildings, or to alter ecosystems. Air pollution can be found indoors or outdoors, and it may come from natural or human sources. So I'd like you to take a moment to consider air pollutants that you are aware of and write down perhaps 3 of them. Once you've done that, see whether those air pollutants which you've written down fall into the category of chemicals, particulate matter, or microorganisms. So hopefully you thought of a few items that you might have heard of in the news that fit into one of these categories. An example of a chemical air pollutant might be anything that smells bad, like acetone from nail polish, or it could be things like radon gas. It could be acids and acid rain. Those are all examples of chemicals. Particulate matter means tiny pieces or tiny particles of physical material like dust and smaller that can be breathed into the lungs and cause damage. There are a number of categories, but one thing that might be simplest to come to mind is asbestos. Asbestos is a mineral material that gets into the lungs and causes damage, and we'll talk more about that later. The third category might have been one that you had a little trouble finding an example for, but it's really all around us. Microorganisms like mold here on Cape Cod are in our homes often, and they can cause people to have breathing difficulties, especially people who have asthma and things like that. And there are other microorganisms too. There's one called Legionnaire's disease, and I'll tell you about that later, but it was a microorganism that was found in air conditioning vents at a Legionnaire's convention and ended up killing quite a few people who were attending that convention. Okay, so again, chemicals, particulate matter, or microorganisms found in the atmosphere at high enough concentrations to cause harm to plants, animals, and materials, such as buildings or alter ecosystems. Can be indoor or outdoor and may come from natural or human sources. So next we'll take a look at some of the major air pollutants. Major air pollutants fall into 2 categories. The first set of air pollutants are called criteria air pollutants because through the Clean Air Act of 1970, the EPA, which is the Environmental Protection Agency, set criteria for what concentrations these 6 pollutants are deemed unsafe. So the 6 pollutants are shown here on the left: sulfur dioxide, nitrogen oxides, which means 1O or 2, carbon monoxide, particulate matter, tropospheric ozone, and lead. So the EPA set criteria and said if these are higher than these criteria limits, then that particular city or industry was causing pollution. And therefore, that made them subject to things like less highway dollars and other types of incentives or disincentives that allowed cities and private industries to try to work toward cleaner air. But those aren't the entirety of all known pollutants. Over time, other air pollutants have been recognized and monitored. Some of these have had regulations put in place. Sometimes the regulations have been put in place but then rolled back. These air pollutants include carbon dioxide, volatile organic compounds, which are abbreviated VOC, mercury, and other compounds. So next we're going to look at a table from the textbook, and the table goes through each of the pollutants. And we will look first of all at the name of the pollutant and how it is written in its chemical formula. Then we will go through the chart looking at the sources for each of these pollutants and see if there's a common theme that can be noticed. And then last, we'll look at the health effects of each of these, and again, look for a common theme. So this table of major air pollutants I have fit onto two screens. So we'll take a look first at this screen and the chemical symbol for that pollutant. So first we have sulfur dioxide. Sulfur is that chemical that smells like rotten eggs. And di means two, and oxide means oxygen. So we have a capital S for sulfur and a subtext 2, which means there are two oxygen atoms attached to one sulfur atom to make up sulfur dioxide. The second one is called nitrogen oxides. So notice it doesn't say nitrogen monoxide and nitrogen dioxide. It just has a little X here in the subtext. That's because both nitrogen monoxide and nitrogen dioxide, so one oxygen or two oxygens attached to nitrogen, are both air pollutants. The third one is carbon monoxide. Mono means one, oxide, again, oxygen. So it's one carbon and one oxygen atom bound together. That's different than carbon dioxide, which has two oxygen atoms. Next, we have particulate matter. That's written with a capital P, a capital M, and then a subtext of either 10, meaning smaller than 10 micrometers, or 2.5, which is super small, very small, smaller than 2.5 micrometers. Next, we have lead. Lead is written with capital letter P and a lower letter B. The origin of the word lead, the origin of the symbol for lead, the PB, is from a Latin word, which is plumbum. Plumbum is spelled P-L-U-M-B-U-M. So I suggest you write those letters out, plumbum, and take a minute to think what other words begin with those first 5 letters, P-L-U-M-B. You can put this recording on hold if you like. Hopefully you came up with the term plumbing. And in fact, the Roman civilization actually used lead to line their plumbing. And that included the plumbing that brought water to their households. And according to Neil deGrasse Tyson, who you may have heard of, that is actually one of the theories about what led to the fall of the Roman Empire, because lead impairs the nervous system and people can go crazy and die from it, and therefore that may have led to the fall of the Roman Empire. Now I'm going to move on to the next slide so that we can see the remainder of the table. Then we'll come back to this one to look at the sources and the impacts. Okay, so now we're continuing on with the remainder of the table and looking for the chemical formula for each element or compound. The next one is ozone, and that is oxygen atoms. There are 3 of them, as indicated by the subtext 3, that are bound together. That's different than oxygen, the molecule that you breathe in. Oxygen, the molecule that you breathe in, is O2, or 2 oxygen bound together. 3 remaining air pollutants are the volatile organic compounds, which are written VOC, and mercury, which is written with a capital H and a lowercase g. You might be wondering why mercury has the symbol capital H, lowercase g. Mercury was originally called quicksilver. If you picture mercury, if you've ever seen it on TV or the internet, it looks like silver, a liquid type of silver. And so the original word for mercury was hydragyrum. Gyrum was the word for silver, and hydra meaning water, so it was like water silver, or quicksilver, now known as mercury. Okay, the last compound on the list here of pollutants is carbon dioxide. Again, that's 1 carbon with 2 oxygen atoms, and that's probably the one we're most familiar with when thinking about air pollutants. Now we're going to go back one slide to look at the top of this table and look at the sources of air pollutants